as fast as we can. We need to get really good at using robots. We're going to have robotic missions to the moon before we have humans go to the moon so that we can get the most out of our human science missions. And that's true on Mars as well. This president and vice president are very committed to getting America back to the surface of the moon as fast as possible. Earth, because we live here. And it's the only planet we know that can host life, so we better take care of it. When I was 5 years old, they made us draw what we wanted to be when we grew up, and I drew a picture of an airplane. I had a picture of myself there wearing a hat that I thought airline pilots wore. As a pilot in the Navy, I became very dependent on space-related capability, and a lot of the technologies that come from NASA have multiple uses and have transformed the way we live our lives. So people say, why are you interested in space? I think the question is, why wouldn't you be interested in space? It's critical to our everyday lives. So this is a critical mission for our country. It's a critical mission for the world. These are some of the brightest minds that our country has. We've got great international partners, and our nation is grateful, and in fact the world is grateful for their service.
It is great to hear from our new NASA administrator. Now remember, you can follow him on Twitter using @JimBridenstine. We're now a little more than 9 minutes away from today's launch. Let's go to NASA's Joshua Finch in the Mission Director Center for the final countdown of today's launch. Josh?
Thank you very much, Stephanie, and I'm actually being joined by Alyssa McBeth from United Launch Alliance. Alyssa's going to give us a little more insight in today's mission. Alyssa, can you tell me about your role at ULA and what it's like to work for Insight?
Yeah, thanks for having me here. So I work at the launch site. I'm a systems engineer for launch operations, mainly in the avionics department. So that covers everything from batteries to harnessing to the flight boxes that takes the rocket to where it needs to go in outer space. My personal role, I'm also involved with ordnance, so installing all the pyrotechnics that separate the stages, separate the spacecraft from the vehicle on orbit, those kinds of things. So that's mainly what I'm involved with. And on Insight, I was able to, it was my first West Coast launch, and on Insight, I was able to come out here for the past couple of weeks and do just that, install batteries, install some ordnance, and do some final connections.
So you're often on console for ULA launches. Can you tell us what it's like to be on console?
Absolutely, yeah. So on console it's an experience. It's very exciting. The adrenaline in the room, you can feel the energy. There's a lot of system testing happening just to prepare the rocket for launch and verify that everything is in configuration and nominal. We fuel the rocket at that point, T-minus 2 hours and counting. And then it's really just some final checks to verify that everything is good. We've got a team of people at the launch site sitting on console, as well as our certificate.
So can you tell me what's happened up to this point in the countdown and what we can expect before launch?
Yeah, so we're getting up to the terminal count now. So terminal count is T-minus 4 minutes and counting. So up to this point, the rocket is fully fueled. We're doing some final system checks. All of the testing that I talked about earlier is completed, and we are doing our final, we're ready to go. So we'll get into a status here soon. All the systems will go through and say, yep, we're good to go, and we'll be ready.
And we're about 10 seconds away from that pull now, so let's listen in.
Okay.
LCAC.
7 minutes.
LAC. Confirmation from OS that we are in the correct RF patch configuration. Roger. Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. Has-gas. Go. Electrical systems. Airborne. Go. Ground. Go. Facility.
Go.
RFFTS. Go. Flight control. Go. GC cubed.
Go.
Com. Go. Umbilicals. Go. ECS.
Go.
Redline monitor. Go. Quality.
Go.
Ops safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. AC is go. Range coordinator. Clear to proceed. Launch director.
LC, you have permission to launch.
Proceeding with the count. ALC verified T0 is set for 11:05 Zulu. Verified. OS start list data capture.
And as you've heard, that poll is now complete. We are still within the whole of the T-minus 4 mark, but with the L clock, we're about 5 minutes, 40 seconds away from launch. And Alyssa, one last question for you. You have teams working at this launch site, and then you have teams in your company headquarters in Colorado. Can you tell me about how they're working together?
Yeah, definitely. So in Denver, like I said, those are our certified responsible engineers. So these are the experts in the system. They know everything down to the minute detail. So they're looking at the data as an overall system, but also digging into the details. At the launch site, we're in the countdown. So we're running the tests. We're sending commands. We're pressing buttons and doing those kinds of things, and working together with them as a full team, ULA team, to get it ready.
Sounds great, and thank you very much for being with us today for the launch, and we'll continue the countdown. Thank you very.
Thanks so much.
And with that, we'll continue keeping track of all the things that are happening as we lead toward liftoff. So let's get you up to speed. And first, welcome to those who are just joining us on social media. As you can see, we have a little bit of fog in the area today. You can see the Atlas V and its 401 configuration, and it's stacked on the launch site at Space Launch Complex 30, the West Coast launch site for the Atlas V. The Atlas V has many different configurations, but this 401 configuration means that we have a 4-meter payload fairing at the top. The 0 indicates there are no solid rocket motors for this mission, and the 1 indicates we have a single-engine Centaur upper stage. We are about 10 seconds away from coming out of the hold in our count. 4, 3, 2, 1. And we are at T minus 4 minutes and counting. That's 8, 7, 6, 5, 4, 3, 2, 0. Liftoff of the Atlas V, launching the first interplanetary mission from the West Coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Check pressures and RPMs. Expect command at this point. RD-180 continues to look good at this point in the mission. Check pressures, pump speeds, expected regions, pressure ratio, controlling within expected parameters.
The RD-180 engine providing 860,000 pounds of thrust.
Vehicle body rates continue to look good. All booster systems look nominal at this point. Mach 1.
The rocket is now traveling faster than the speed of sound. Coming up the rocket will enter max Q. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Coming up on the throttle down. Booster has throttled back, right on schedule. Signatures look good. Pump speeds, injector pressures continue to look right within band. Body rates controlling down the middle. Current altitude is 13 miles, downrange distance 7 miles, current velocity 1965 miles per hour. Closed loop guidance has begun.
The first part of the flight was pre-programmed trajectory. Now the rocket is giving itself feedback on its flight path.
And Q alpha steering has begun. Body rates look good. Pump speeds, injector pressures, all within band. RCS pyro valve has been fired. System is now pressurized at flight level. Signatures look good. Current altitude is 30 miles, downrange distance 43 miles, current velocity 4,542 miles per hour.
You're looking at a live view from the Atlas V rocket. The RD-180 engine continues to burn.
Flight rates continue to look good. RD-180 is still performing well. Q alpha steering has been completed.
To burn. You're looking at live animation telemetry
Rates look very good.
of the Centaur second stage on its flight path.
Our GN2 purge firings underway for thermal conditioning. Pump
As you can
speed,
see to the bottom right of your screen, the flight path of the rocket.
discharge, all in band for the ZMR.
and Centaur has gone to closed loop view control in a slightly fuel-rich mixture ratio correction. And a quick look at the booster stage performance shows a very nominal booster.